Hello, lovelies. I am your celebrity mathematician, Omale Jeffrey Jojo, and with my marker and my professorship sign or professorial sign, yes. Don't mind me. So, my attention was drawn to a beautiful question by somebody with upper and lower band. You know what I mean? That is integration. And it's FUTO 2010/2011 objective questions. Objective question number 38. Yes. And it says evaluate integral to 0 cos squared x dx. Yes. So the first thing to do, whether you know it or not, is to write solution so that the person beside you will have hope. So imagine FUTO giving this as an objective question. Now you cannot solve this directly. From primary 5 or so, we all know that when we have cos A plus B, it will be equal to cos A dot cos B minus sin A dot sin B. There's a secret here. The secret is that cos is always the stingy man. He changes his sign and first carry everything, as some of us do. Then before he now give to his brother sign. But in case of sign, it's not like that. We're not doing sign today. So let me focus on the cos that we are doing. Now, we all know as well that when I have cos squared A plus sin squared A is equal to 1. Right? Now, if we know this and we believe this, it implies that if I have cos 2x, yes, cos 2x, which is the same thing as cos s plus s, it will be what? Cos s minus sin s dot sin s, just by applying this principle. So this will now give me what? Cos squared x minus sin squared x. Yes. Some people may think that I want to have s squared. No, because x is the angle. We are just doing justice to the cos. So, and if I have this, which simply means cos squared x plus sin squared x equal to 1, because I can take my AA to be this, right? So if I have something like this and I'm working on it, so this simply means, it implies that in this way, since I'm working with cos, I'll change everything to cos, so I'll make this the subject of formula. It implies that my sin squared x will now be 1 minus cos squared x. So if I have this, I'll now go to this place, my cos 2s, which is this, and I'll substitute the value of this sin squared s so that everything can be cos for me to solve. Right? Now, if I have it like that, it simply means my cos 2s will now be equal to cos squared x minus, the same minus here, 1 minus cos squared x, because the value of sin squared x is what I put here. So this will now be equal to what? Cos squared x minus 1 minus will change to plus, then cos squared x. So since I have cos squared s, it will give me 2 cos squared x. So this 2 cos squared x minus 1. So this minus 1 will cross the sign of equality to meet this one and change to plus. So it simply means cos 2x plus 1 is equal to 2 cos squared x. Now, if I have it in this way, it simply means for me to find my cos squared x, I'll divide both sides by 2. So therefore, cos squared x will now be equal to cos 2x plus 1 over 2. So it's from here that we can now substitute inside this to solve. Imagine an objective question. So let's see what to do. So remember, the value of cos squared x is cos 2x plus 1 over 2. Good. So it simply means the integral pi over 2 to 0 cos squared x, the x will now be integral pi over 2 to 0 cos 2x plus 1 over 2 dx. You see it? So it's from here you can now integrate. And remember, there's something I was supposed to do here. This thing is the same thing as what? Integral pi over 2 to 0, 1 over 2, because these 2 here. Then I now have cos 2s plus 1 ds. Good. Whenever you have, even if it's over 4, what I'll do is to put 1 over 4 outside and integrate. Good. Now, with that 1 over 2, let me manage my space. 1 over 2 equal to cos 2s. If you integrate cos, you have sine. Since there's 2 here, the 2 will be down. I have sine. That is sine 2s over 2, right? Sine 2s over 2. Then if you integrate 1, you have plus. You have sine. Sorry, as a sine. If you integrate 1, you have x. Anytime you integrate any constant, you have that constant with x. I didn't mean it's 2, I have 2x. If it's 1, I have x, because it's a constant. Unlike differentiation, but when you differentiate, constant is 0. So you now have this, the bound pi over 2 to 0. Now what you do here, if you have bound like this in a definite integral, you first substitute the upper bound minus substitute the lower bound. There is it. 1 over 2 will be out there. I'll use pi over 2 first. Now I have sine 2. Whenever I see x, pi over 2 over 2 plus pi over 2. I'm done with here. This is the upper bound minus sine 2 0 over 2 plus 0. Good. Can you see the beauty of it? So now pi over 2, remember this 2 here can go with this 2. So I'll now be left with pi. This now give me 1 over 2, right? Same way, I now have sine pi over 2 plus pi over 2 minus sine 0 over 2 plus 0. Because 2 times 0 is 0, so I have sine 0. And the 0 is there. Now, there's some beautiful thing here I want to do for us not to waste our time. Here, sine pi is the same thing as sine 180 degrees. And sine 180 degrees is 0. 0 divided by 2 is 0. So what I have here is equal to 1 over 2. I now have 0 over 2 plus pi over 2 minus sine 0 is 0 divided by 2 is 0 plus 0. Good. Now 0 divided by 2 is 0. So I now have 0 plus pi over 2, which is pi over 2. So what I'll have left is 1 over 2 pi over 2, because 0 divided by 2 is 0. 0 plus pi over 2 is 0. 0 plus 1 million is 0. Let me check my speaker. Is 0. 0 plus 1 million. So I know that when I say 0 plus 1 million is 0, your money in account you'll be thinking 0 plus 1 million is 1 million. 0 plus 2 billion is 2 billion. But when you multiply, it will now cancel everything. 0 times 1 million is 0. So when you are adding 0 to any number, is that the same number? 0 plus u is u. Do you understand? So 0 plus pi over 2 is pi over 2. Then 0 plus 0 is 0. So what I'll now have is minus 0. Now, pi over 2 minus 0 is pi over 2. So I'll now have 1 over 2 pi over 2. So 1 over 2 times pi over 2 is pi over 4. So I now have pi over 4. And that is the answer. So if you're there, you can believe that the integral, the definite integral of cos square x dx with upper bound pi over 2 and lower bound 0 is pi over 4. So thank you so much for joining me today. I'm Omalejo Fejojo. You can do me a favor by subscribing to my YouTube channel and share the educative videos for humanity's sake as we aim to achieve zero illiteracy. Because without this, modern technology would be unthinkable. Thank you so much.